What's up, everybody? This is Mr. Williams, and I'm coming at you still talking about our radicals. So, in the previous video, we added them and subtracted them. Once before that, we simplified them. Today, we're going to multiply. So, we're just going to go through these problems, a couple of these anyway, and we're going to go by these little guidelines right here. This is what I like to use. So, when you're multiplying them, you just multiply the coefficients, multiply the radicals, and you simplify. It's real simple. All right, so let's just jump right in. Let's look at this one. So we have radical 6 times radical 2. Well, we're just going to go ahead and multiply those radicals, gives you radical 12. Now you got to simplify that. So this goes back to what we've done before. These are 2. Sorry about that. You know, my writing gets a little upside down. And this group becomes a coefficient that goes in the front, and the 3 is. So there we are. We have multiplied that one. Let's look at number 16. Number 16 is a little weird. And for the sake of this video, all of our radicals will have the same index. So we're not going to be multiplying two different radicals that have two different indices. And the reason why is because that gets into that's a whole nother topic, a whole nother video, because you got to do some conversions and stuff. So for the sake of this video, all of our radicals will have the same index. Same thing here. Let's just go ahead and multiply that. So we're not dealing with a square root, we're dealing with a cube root, but you still do the same thing. 9 times 3 is 27. And we can break that down. We can do that into 3 times 3, which is 9, times another 3, which is 27. Notice I took a little shortcut there. Instead of me doing 9 times 3, I just wrote 3 times 3 times 3. Why? Because I want them in groups of 3. I want 3 factors in a group because that's the index. If the index is 3, put them in groups of 3. If the index is 6, put them in groups of 6. That's a previous video. But anyway, so the 3, this group becomes a coefficient. Nothing's left over. We don't need a radical. That's real simple. That's our answer. It's 3. Okay. Let's go down to another one that's a little bit more tricky. Let's look at number 21. What's going on here? Well, here we're still multiplying, and we're going to go by our same rules, but we got to use distributive property. So we're going to do radical 15 times 2 radical 10. Well, this coefficient is a 1. So if you multiply the coefficients, 1 times 2, 2. Multiply the radicals, 15 times 10, 150. Now, we're going to go and multiply the same radical times the second term. So radical 15 times radical 4 radical 6, that gives me 4, and 15 times 6 is 90. 4 radical 90. And we're going to put our minus sign back in the middle. So we're done with the multiplication piece. Now we got to break all of this down. So let me give myself a little bit more room here. So 150, we're going to break that down into 25 times 6, 5, and 5. Now, as you may remember, when you have a coefficient already in the front, you got to multiply it times your group. So that's going to be 5 times 2 is 10. Leftover is 6. So 6 goes under the radical. Got 10 radical 6. And again, how did I get that 10? Well, because remember, this group is going to come out to the front. So you have 5 radical 6, right? But there is a brown 2 already there. So you got to multiply it. That's how I got the 10. So now let's break down this 90. If I have enough room, 90 will do 9 times 10 and 3 times 3. So my group of 3s will become a coefficient. It's going out to the front. So that 3 times the 4 that's already there is 12. The 10 stays under the radical, it's left over. So we got 12 radical 10. Now, you could break the 10 down into 5 times 2, but you can't remove anything from under the radical. There are no perfect square factors, so we leave it. We're going to put the minus sign in the middle, and we cannot simplify this any further. There are no ways to remove anything from under these radicals. They're not like radicals, so we can't subtract them. So we're done. That's how you do that one. Now I'm gonna erase this for the sake of room. So if you just need to write all of that down, just pause the video. Okay, going to number 22. Number 22, we're gonna go back to some Algebra 1 stuff. This is good here, man. So here we have to use our FOIL method. We've got binomials here, a -7 and a radical 3x. All right, well, let's just jump in. So we've got -7 times 4. That's -28. That was just regular numbers, so that's okay. Now we got to do -7 times radical 3x. Well, multiply the coefficient, which is 1. So we've got -7. So let's do plus -7 radical 3x. And now we're going to do 3x. Let's come down here, multiply the other half. Negative radical 3x times 4. That gives me 4 radical 3x. And again, this is a plus sign in the middle because everything's plus, everything's addition. And the last one, 3x times 3x. This is a good one here. So this is going to give us radical 9x squared. How did I get that? Because 3 times 3 is 9, and x times x is x squared. Okay? So now we've kind of expanded all of this. So let's simplify it. Let's see what we can do here. Well, first thing I notice is that we've got like radicals. We've got 3x and 3x. So let's go ahead and combine those coefficients. -7 plus 4, that's -3 radical 3x. And not going to touch the -28, really nothing to do there. Oh, but something special going on here. So we know that this can be broken down into basically the square root of 9. Well, let's do it like this. 3 times 3 and x times x, right? So these 3's are paired together. I'm sorry about my writing, y'all. That should be a 3. And these x's are paired together, so both of these are going to come out from under the radical. So you're going to have a 3 and an x on the outside. Let's just put it in front of this. So we've got 3x right there. The -28, let's just put that in the front. So we've got -28 plus 3x minus 3 radical 3x. Whoa, that's crazy. Now, don't be confused. The 3x and this 3x, they are not the same because one has a radical. So we can't combine them any further. We can't combine the -28 and the 3x because the middle term has an x. So there are no more like terms. There's no other ways we can simplify this. All right. So we're done. So when you're multiplying radicals, even when they get crazy like this one, or if they're simple like the first one we did, just follow these rules. Multiply your coefficients, multiply your radicals, and simplify. That's all I did. Here I just had to kind of remember my FOIL method. Now, some people have learned it using the box method. You can do that. That's fine. You just got to set that up. We would do -7. I'm not going to go through it, but I'll show you how to set it up. And then the radical 3x is going to go here at the bottom, getting a little messy. But then the 4 would go here. That room, the 4 would go here. Sorry, I'm using my mouse, so that's a 4. And the radical 3x would go there. And then you would just multiply it using the box method. But there you go. So have fun. Good luck with your future work, and leave me a comment. Hit me up if you have any questions. If you see a number, you don't know where I got it from, or if you're kind of confused, or even if I did something wrong, then let me know. All right. But good luck on your future work. Hit me up if you got any questions. Have fun.